1.412b. We started talking about this one. I think we got as far as direct substitution, right? You got the limit as x goes to 6 from the right-hand side. Direct substitution does give you 0 over 0. And what else did we say yesterday after that? What's causing the 0 in the denominator? How about that? Identify the bad guy. The absolute value, because really there's an x minus 6 causing it. 2x minus 12 is just double that. So the 2x minus 12 factor is causing the 0 in the bottom, and it's in the absolute value, and it's linear. And in the top, we have a quadratic, but we know, of course, a quadratic will factor possibly into 2 linear factors. And I'm guessing one of those linear factors is what? X minus 6. Because remember, when we did the factor and divide out method, if you plug in a 6 and get a 0, x minus 6 is a factor. So the jump man is embedded in this problem. And to use the trick of plugging in a number to the right of 6, as we saw in the warm-up, you have to isolate it, right? So what you have to do first, I always write this first, write the limit. You have to factor the top. So it's going to be x minus 6 times x minus 2, yeah? And then down here we have the absolute value of 2x minus 12. Now you don't actually have to have x minus 6 over the absolute value of x minus 6. As long as it's linear over linear and you isolate it, you can do the jump man trick. So on the next step, which is optional, I'll go ahead and show it. I'm going to take the limit as x goes to 6 from the right of x minus 6 over the absolute value of 2x minus 12 times the limit as x goes to 6 from the right of x minus 2. So I'm just physically giving each of them their own limit just so I can visually see it as like 2 separate problems. As we saw in the warm-up, though, you don't have to physically separate it as long as you're plugging in the right values into the correct things. Okay, so let's look at the first factor. Linear over linear, that's the 0 over 0. That's jump man. We're approaching from the right of 6, so we could choose what? 7, 8, 108, whatever. Bless you. I'll choose a 7. 7 minus 6, 1. And 7 times 2 is 14 minus 12, 2. And the absolute value of 2 is 2. Okay. So does that mean then also that I also plug in a 7 over here as well also? I plug in a 6. It's a separate problem. 6 is right there. Direct substitution, 6 minus 2 is 4. And then 4 times a half is 2. Yes. So this would definitely be one of the answers. What do you think another answer would be? If you plugged in 7 for everything, you'd get a 7 minus 2, you get a 5 instead of a 4, you'd get 5 halves, right? And there might be 1 or 2 people that take that, but not y'all. I would make D and E an answer choice, yeah. Now, what small little adjustment can I do to the original problem to make the whole thing D and E? Good. Just get rid of the right-sided limit. Because now if it's just the general limit as x goes to 6, I got jump right here at 6, which does not exist, times 4, right? So it does not exist. Good. And of course, if that had been from the left instead of the general limit or the right-sided limit, the only difference is you would plug in maybe like a 5 or something into here, and you'd probably get a negative 1/2, okay? So isolate the jump man, and then you can do that trick. All right, so step 1 on part C is to find the missing symbols. 3x minus 21, x squared minus 49. On your marks, get set, go. Do it yourself. Oh, I think it's supposed to, yeah. I think it was supposed to be the general one, but let's make one up. I'll just say from the left. I think last year we did the, yeah. It might be. Let's make it from the left. What would the general limit be? Maybe D and E. Yeah, so let's make it from the left. Because when you plug in a 7, you get a 0 in the top and a 0 in the bottom. And it's not a whole because you have Jumpman. You have a linear function and a linear function embedded in the quadratic. So that's the only time 0 over 0 means D and E for the general limit. If it's Jumpman. while you're doing that one, let me make another one up then here. Bless you. You get it? It's good, good. I don't have it. Can't do it. Sine of 7, sine of 7. Just leave it. Yeah, it's not a unit circle angle. You do not need to factor out a common factor from either of the linear terms for Jumpman. You could just leave it in there. So like the 3x minus 21, you're certainly welcome to factor out a 3 and call it x minus 7. But as long as it's linear, it'll work. And it's almost just easier to leave it in there because you're going to absorb it when you plug it in. That's a good question. Jumpman is always 0 over 0. So if you've already plugged in a 7 and you got a 0, it's because it's x minus 7 over x minus 7. So the 3x minus 21 is really x minus 7 times 3. So that, of course, has the absolute values. And x squared minus 49 is x minus 7 times x plus 7. The x minus 7 has to go with the Jumpman because that's the 0 over 0. Okay, the x plus 7 is causing a 14 when you plug in, not a 0. So he can be associated with the good guys. You got the bad guys and the good guys. So if you go straight from that line on top to the one I wrote, that's pretty efficient. Now direct substitution, what do we plug into here? A 7. And you get sine of 7 all over 14, which is a number, times what? You plugged in a 6? Something to the left of 7, right? So 18, if you plug in a 6, you get 18 minus 21 is negative 3. The absolute value is positive 3. All over 6 minus 7 is negative 1. Yeah. So your final answer is negative 3 sine of 17 over 14, or negative 3 14. Sine of 7, oof, not 17, yeah, 7. There we go. Negative 3 sine of 7 over 14. Isolate Jumpman. One-sided limit, plug in a number from either side. Well, the bottom's negative, the top is positive, because it's absolute values. I just threw the negative in the top when I rewrote the final answer. All right, last one, bonus one. Scroll down, write this one down. The general limit. This one's a general limit. General limit. General limit. General limit. D and E, anyone? Wow, y'all are doing well. Yeah. Yeah, never not first, right? Plug in 13. 13 minus 3 is 10. Absolute value is 10. 13 minus 3 is 10. 10 over 10. 10 over 10 is 1. Okay, so good. I tried to trick you, right? It would be D and E, the general limit, only if I'm approaching what value of x? 3. And I put 13 there thinking maybe you wouldn't see the 1. Yeah, but you saw it, right? Totally cool. So don't jump to conclusions. All right, example 13. Here we go, right before lunch. We're moving on then from Jumpman to now Trig, what I'm going to be calling in general Trig manipulation. But it requires a little bit of an investment. So here we go. It says, with the calculator, evaluate the following and then memorize the results. All right, the limit is x goes to 0 of sine of x over x. What's the plug-in going to give us? 0 over 0. Is this Jumpman? No. So we're back to 0 over 0, meaning there's a hole, which means the limit will exist. Do any of the algebraic methods we've talked about so far work here? Can I just divide out these x's and call it sin? That is a sin. It makes no sense, okay? So that doesn't work. So you do have to go to the calculator. So if you want to play along and you have one, feel free. I will demonstrate up here, though. And we'll go with the big screen. Come on, SmartView. What mode should we be in? Radian mode. Yeah. Why is it not showing? Show all. Okay. It's not showing up. Okay, so imagine I'm typing it in. There it is. As soon as I quit, it goes away. It shows up. Y equals sine of x over x. If you have an old TI-84 and it doesn't have the Smart View on it, I can give you the new operating system with this cord. I gave it to someone last period, so it's kind of nice. I will be demonstrating with the Smart View version all year long. So if I go to y equals, I'm going to save this one for another class period. Let's go to y sub 2, sine of x, close parentheses, divided by x. That's a little bit faster than the horizontal division bar. Zoom 6 is the standard viewing window. And we're approaching 0, right? So the graph is pretty good just for visually determining whether or not it exists. Do you think it exists based on the graph? Yeah, it appears that these two red lines are lining up with each other. Of course, the function doesn't exist there. Because it's scaled by 1, you might be able to infer even what it is, right? What does it look like? It looks like 1. Now, with the calculator, of course, we don't just say it's 1 because we want some numerical evidence. So if we hit the trace button, negative 0.001, that's pretty close to 0. You get 0.9999999, and then from the other side, 0.0001, you get, uh-oh. Is that right? Is that right? That's not right. I broke the calculator. I didn't break it per se, but I made it submit to my will. I owned it. I dominated it. I overloaded it with zeros that it cried uncle and gave me the value that I want. So let's just back off on some zeros, show a little bit of clemency and mercy, 0.99999, okay? But enough evidence is there to then determine that the limit is what as we approach 0? Uno, okay. Memorize it. Got it? What's the limit as x goes to 0 of sine of x over x? 1. Good. What's the limit as x goes to 0 of, what's the limit as x goes to pi of sine of x over x? The limit as x goes to pi. It'd be sine of pi over pi. What's sine of pi? 0 over pi is 0. Okay, so it's only when we're approaching 0 that we get 0 over 0, and we just decided that the limit was what? 1. Okay, good. Memorize it, memorize it, memorize it. You remember these? All right? Now that you've memorized it, let's work down. What do you think the limit is as x goes to 0 of x over sine of x? D and E? Did y'all do direct substitution? What do you get? 0 over 0. You still get 0 over 0. Is it negative 1? Well, how is x over sine of x related to sine of x over x? They're reciprocal. So if this function is approaching 0, 1, then the reciprocal should be approaching the reciprocal y value of 1, which is what? 1. Yeah, the reciprocal of 1 is 1. So it should still be 1. The graph is going to be inverted, kind of like we took cosine and graph secant. All the y values reciprocate, so like 1/2 becomes 2, 1/3 becomes 3. They get bigger if they're smaller and vice versa. But 1 stays a 1. So what's nice about this one, because we do have to have it memorized, is we could flip it. The limit as x goes to 0 of sine of x over x or x over sine of x are both 1. Okay, what do you think about this one then? Sine of 5x over 5x as we approach 0. 1, 5? When you plug in a 0, you still get 0 over 0, which means it's still indeterminate. But is it still 1? Why? Do these 5s divide out? Give you sine of x? I like that, yeah. Let's think of what the graph of sine of x over x looks like, right? We just graphed it. There was an open circle there, and it was doing this. Yeah? All we've done is we've taken the x and replaced it with a 5x. So think transformations. When you replace x with 5x into any equation, what do you do to its graph? Horizontal compression. We've compressed it by a factor of 5. So all of your x values are coming in by a factor of 5, which makes the graph kind of have like a smaller frequency. But we're approaching 0, right? So what happens when you compress 0 by a factor of 5 when it gets to 0? It stays the same. Yeah. So because you're just stretching it and or compressing it equally on either side of the y-axis, and we're approaching the y-axis, this should still be 1. What do you think that is then? It's also 1 because what does this do to the graph of sine x over x? Which way? By a factor of what? 2. Yeah, so it doesn't matter if you're stretching it or compressing it. Like you're playing the accordion, because 0, 1 stays put. When you stretch it or compress it horizontally, it's still 1. So let's think about that. We're kind of summarizing some things here. As long as it's sine of, let's say, ax over ax, where those numbers match, and we're going to 0, it should be what? 1. Now, what do you think? We haven't done this one yet. What do you think if I flipped it and changed the number? So what do you think the limit is as x goes to 0 of 4x over sine of 4x? Should still be 1, right? So sine of x over x, as long as you're approaching 0, you could flip it, or you could stretch it or compress it, and you'll still get 1. Now this one is supposed to have minus signs. The limit as x goes to not 0, but what? 4 of x minus 4 over sine of x minus 4. That's different. What do you get by direct substitution? 0 over sine of 0, which is 0. Frenchie, what do you think it was? It is 1. Why? What does replacing x with x minus 4 do? Shifts it to the right 4. What value are we approaching? No, 4. So the old 0 is now 4 to the right at 4. So we're approaching the same spot on the graph, but in a different location. All right. Have a great lunch. Refuel.